Hello, welcome to the Sunflower Project. I'll introduce you to the concept and demonstrate how this project works. In the Northern Hemisphere, fixed solar panels are often placed to face southwest skies to capture maximum solar radiation. However, these panels throughout the year can only capture about 32% of the total solar radiation available for that region. However, a movable solar panel that can track the sun can be up to 94% efficient. Commercial setups are expensive and depend on an internet connection to accurately position themselves to track the sun. My project is an attempt to create an autonomous solar tracker that follows the sun irrespective of the location, date, and time. Let me introduce you to the model. On the left hand side, we have the control panel, and on the right side, we have the setup. On the control panel, you can see that we have two modes, demo and real modes, controlled by a toggle switch. And demo mode can be either in demo set mode or demo run mode, as you can see on the right. As you can see, the program is resetting. It is in demo mode. The first thing we see is that it repositions the altitude motor to home, then it repositions the azimuth motor to home. Once that's complete, it enters demo set mode. I'm going to reset it. It's starting once again. Altitude motor resetting. Okay. Azimuth motor. Now it's in the demo mode. In the demo mode, we have the opportunity to turn the knobs to choose a place in the northern hemisphere, and the second knob, the month, and the last knob is day. We have over 12 locations to select from. I have Tokyo at the very end of the eastern longitude, and to Honolulu at the very end of the western longitudes. Let me turn the knob very slowly so you can see all the locations. We can select the month with the second knob, and let's choose May as our month. So that's 5. For day, let's select 6. The day I have limited to 28 days because, for obvious reasons, I don't want users to crash my program by selecting February 31st. That would not be valid. I want to keep this simple and small. By the way, year has no significance, as every year for the position calculates in Sun-Earth geometry. Having set the place, month, and date, I'm going to set it to New York. I'm going to switch this to run and reset the program. We can go through the reset process once again. It's starting on. We're in demo mode. You can see that we're running the demo mode for New York for May 6th. The motors will reset one more time, and I did this to make sure if you ever stop in the process in the middle, it will always go back to the last position to trace the steps back home. Alright, now that's done, we can see that it's 8 a.m. solar time in New York. We can see that the latitude and the longitude of the city. Right now, azimuth, altitude, it is 11 a.m. The process goes on, shows the azimuth angles and the altitude angles. The motors reposition every 10 seconds as incrementing by 1 hour in true solar time. NAN means that it is not a number. So this demo mode runs from 8 a.m. to 9 p.m. solar time. So it can go by fairly quickly as opposed to the real mode, which I'll show you in a minute. Now let's change it to real mode. Or I can just wait for it to be done. It's 4 o'clock. Five o'clock. Longitude, azimuth, altitude. 6 o'clock. 3 more hours. The azimuth won't move anymore because it's over 270 degrees. Okay, right now it's 8 o'clock. So the program, the demo run mode is done, and now it's resetting to the original program and going back to its home position. Now let me show you the real mode, which actually follows the sun in real time. So you change the mode into real and hit reset. It doesn't matter in the other toggle switch because it's not needed. Starting. That's the GPS antenna right there, which is trying to capture the GPS fix, but since we're inside, it will not, and we'll use the default coordinates, which are OMS middle school's coordinates. The LCD display shows that it doesn't have the coordinates, and we're using OMS coordinates. This program is going to move every 10 minutes because I don't want to move it too frequent because the azimuth and altitude angles will barely change every 5 to 10 minutes. So if I move it every 10 minutes, it can have some variation.